Here's some different problems that were covered in these sections for logs. There are some videos that I would highly recommend watching, but here's a kind of shortened version of all of it. We have one log. If I have a natural log, the base is always e. If I have a regular log, the base is either given to you, and if it's not given, it's always a 10. So in this case, I can write in an e. Anytime I have one log isolated and only one log, I'm going to go into exponential power. It's this little one raised to the outside, so e to the 2.5 equals x. So now all I have to do is plug it in my calculator and press second ln, which gives you e raised to the 2.5. That means x is approximately 12.18. Same thing here. All I'm doing is going to exponential form. 2 raised to the 5th equals this expression x minus 4. So 2 to the 5th power is 32. So I have 32 equals x minus 4. So I'm going to solve by adding 4 to both sides. And x equals 36. Well, what happens if I have one log on each side? Well, the good thing is if I have only one log with nothing extra, the logs cancel. So now I have x minus 4 equals x plus 3, and I'm going to solve, and actually I just made these problems up, so this one's going to have no solution. But suppose this was a 2, so let's change that to a 2 just for purposes of this problem. So I'm going to subtract x to the other side, so I have negative 4 equals 1x plus 3. Then I'll subtract 3 to the other side, and I get negative 7 equals 1x, therefore x equals negative 7. Well, here's a problem. When I plug in for logs, they cannot be negative, so if I was to plug this 7 in right here, I can't take the log of a negative number, so in this case, I would have no solution. If that was a positive 7, then I would have a solution. Well, what happens here? Well, again, I see logs on both sides, but unfortunately that's not going to help me. So what I'm going to have to do here is make this log base 2 x squared equals 4 plus log base 2 x minus 3. Now what I'm going to do is bring this over here. So I have log base 2 x squared minus log base 2 x minus 3 equals 4. Now I can combine these two logs into one. So I have log base 2, the positive one, which is this one, goes on the top. The negative one, which is this one, goes on the bottom. So now from here I can go into exponential form because I'm to one log. So I have the little one raised to the outside. So 2 raised to the 4th power equals x squared minus over x minus 3. So now at this point I'm going to just get you one step further, and then I'm going to let you finish this. From here I'm going to cross multiply. So what I have is 16 over 1 equals x squared over x minus 3. So if I cross multiply, I get x squared equals 16 times x minus 3. And then you can go ahead and solve from there. Next problem. If I have like bases, the exponents equal each other. So I'm going to change 8 so as a base of 2. 2 raised to the 3rd power is 8, and I still have that x over there. Now that the bases are the same, I can drop them, and 2x plus 1 equals 3x. So to solve this, I'll subtract 2x from both sides, and x equals 1. Last problem. If I have one log on each side, I can drop them. Well, I can combine these to one log. The negative 1 goes on the bottom. So log 2x plus 5 over 3 equals the log of x minus 1. Now that the logs are the same and there's 1 on each side, I can drop them. So I have 2x plus 5 over 3 equals x minus 1 over 1. Now I'm going to cross multiply. 2x plus 5 equals 3 times x minus 1. So on the right hand side I have 3x minus 3, and on the left hand side I have 2x plus 5. So I'm going to subtract 2x, and I'm going to add 3 at the same time. So that will cancel and I'm left with 8. That will cancel and I'm left with x. Therefore, x equals 8.